Hi, I'm Sean Moran with ACC GIS, and our topic today is field data. Now, I want to begin with a project that was completed by our own Leslie Ferguson. She graduated from the program back in 2013 and now works as a senior GIS data analyst with AAA in Florida. And back in 2013, she was taking on her GIS capstone project, and the University of Texas needed somebody to locate recycle bins and analyze their locations on the campus. Now, in this case, this project actually had started the previous spring semester with a UT student. And at the end of the semester, when they collected the data, it was unusable. And so a friend of mine who works at the University of Texas came to me and said, "Hey, do you know somebody who can do this project?" And I said, "Yes, I do." Leslie was just wrapping up her Associate of Applied Science in GIS, and she needed to complete her GIS capstone project. And so I asked her if she wanted to do it, and she said yes. And so Leslie wrote up a statement of work and then went to work collecting the field data and ultimately performing the analysis that you see on your screen. And she did a wonderful job. She used a Samsung Galaxy smartphone and a freeware application known as EpiCollect to collect the location and attributes associated with each recycle bin. Now, in this case, she actually did not utilize the GPS location of the recycle bins. It was pretty clever because her phone was not that accurate. It was going to be, 5 to 10 feet, and she really needed the recycle bins to be within 3 to 5 feet. And so what she did is she set up the technology, but when she went in the field with the GPS device on her phone and also ortho imagery turned on, she used the GPS location to identify where she was on campus. And then she would look and see, oh, there's a recycle bin over at the northwest corner of this building. Then she would look at the ortho image, find the northwest corner, and then manually put the recycle bin on the map. And so she just used GPS to orient and locate herself and then manually put the location based on the ortho image so that the accuracy of her positions was more like 3 to 5 feet rather than the 5 to 10 or 15 feet she would have had with GPS in such a canyon like environment with a lot of tree cover. So it was a really clever way that she did it to collect high resolution data. She populated the attribute and then assimilated the data back in the office and ultimately created this analysis where she identified gaps in the way that the recycle bins are distributed around campus. They have found that if a recycle bin is not near a food establishment or a bus stop, then a lot of the waste goes into the trash can. But if it is, then a lot of the waste goes into recycle bins and gets recycled. And so she found a lot of gaps where the recycle bins were not near these locations and even identified that they needed to purchase about 100 more recycle bins and distribute them around campus so that they could increase the recycling. And the results of this analysis were utilized to present this poster, but also ultimately to reconfigure the recycle bins at the University of Texas. So a really great project that Leslie did. She did a great job for the University of Texas, which was really cool that our students outperformed University of Texas students. And if we look at where Leslie is today, here she is on LinkedIn. She's a senior GIS data analyst with the AAA national office. And if I scroll down, you can see she lists her GIS level 1 certificate and level 2 certificate and her Associate of Applied Science degree and an internship with the University of Texas, which was her GIS capstone project. And she leveraged both her awards and her internship to get her first position as a GIS analyst with GeoTel Communications back in Florida, where her family was from. And then she signed on with AAA and started as a GIS data production analyst, and then has worked her way up to a senior GIS analyst. And so it's a really great field data collection project, but also it's really great how Leslie leveraged both her award and her capstone project with the University of Texas into a job ultimately with AAA. By the end of this topic, you'll be able to collect GPS field data using the field data collection workflow to minimize errors. That includes describing the field data collection workflow, explaining how to plan and configure a mission, listing types of feature level metadata collected with GPS, explaining how to validate, assimilate, and back up your field data, and last, collecting spatial features and attribute values in the field. Now, any GIS project can be pretty complex, but you throw in GPS and field data collection, and it gets downright challenging. Now, the National Park Service works with a lot of staff, volunteers, and other agencies to collect data in the field. And because of this, they've come up with a field data collection workflow for the National Park Service units and personnel, in a sense, to try to standardize the data collection workflow so that they can produce better and higher quality data. Now, their workflow that was originally published on the National Park Service website includes a pre-GPSing, a GPSing in the field, and a roll data into database phase. And so this is more about just collecting the data in the field. Before you go in the field, you need to do some planning, including inventorying your GIS data, your GPS unit, assessing your project needs, developing project management documentation and your data dictionary, and then ultimately planning your mission. And then after you've collected data in the field, you need to post process your data, export it or transform it into different formats and coordinate systems, finalize your GIS data, and then, of course, document your data and processes. Now, the National Park Service GPS for GIS workflow is pretty complex. So, based on my own personal experience, I've simplified it into this field data collection workflow where you plan, configure, collect, and assimilate your data. So, the first phase is planning, where you need to plan for your data, technology, and workflow. The second phase is configuration, where you're configuring your schema, settings, and procedures. The third phase is actually collection, where you're collecting your spatial data, attribute data, and your metadata. And then your fourth and final phase is assimilation, where you're validating your data, assimilating it into your GIS, and backing it up. Now let's look at each of these phases in the field data collection workflow a little more closely.